Hello and welcome to the session on Amazon SageMaker. This video is part of the AWS Certified AI/ML Bootcamp series. On behalf of the CloudExpert Solution team, I would like to thank you for joining us and exploring this video. Amazon SageMaker is a critical topic for both AWS Certified AI Fundamentals and AWS Certified AI/ML Associate certifications. You can expect at least 8 to 10 questions related to Amazon SageMaker and its associated topics. We have broken down the required SageMaker knowledge into smaller, manageable videos to make learning easier. Please ensure you review all the videos related to Amazon SageMaker to gain a complete understanding of SageMaker. We'll start today's topic with Amazon SageMaker overview. Then we'll run through different Amazon SageMaker tool suites. Followed by, we'll review Amazon SageMaker built-in algorithms. Then we'll explore Amazon SageMaker automated model tuning or AMT feature. Then we'll dive deep into Amazon SageMaker model deployment and inference options, and we'll cover real-time inference, batch inference, serverless inference, and we'll conclude with asynchronous inference. Throughout this model, we'll review different use cases and what are the best suit use case for all this inferencing type, and at the end, we'll review a comparative study of different inferencing options available in Amazon SageMaker. We have a lot to cover today, so let's get started. Amazon SageMaker is a fully managed service provided by AWS that enables developers and data scientists to build, train, and deploy machine learning models at scale. It simplifies the machine learning process, making it accessible to users with varying level of expertise. Amazon SageMaker provides a comprehensive set of tools for the entire machine learning lifecycle. It includes feature for data preparation, model training, model tuning, model deployment, and last but not least, model monitoring. Using the model monitoring feature, we can monitor the model and we can use that input to improve the machine learning model. It is a continuous improvement process. SageMaker integrates seamlessly with other AWS services and allowing you to build end-to-end machine learning workflows for your use cases. Now we will review how Amazon SageMaker machine learning model prediction works. And let's assume that we want to predict the future price trends for Apple stock in NASDAQ. To start with, we'll first collect historical data. Historical data includes historical stock prices, including stock open, high, low, close price, and traded volume. We can also take technical indicators, market data like NASDAQ index value, and macroeconomics indicators like interest rate, inflation, and other factors. Followed by, we will perform a feature engineering to create the training dataset from our historical dataset. Then we will build the machine learning model, and then we are going to train and tune the machine learning model. In the tuning process, we are going to work with the hyperparameter tunings such that our machine learning will provide optimal result and optimal prediction for us. Once the machine learning model is ready and we can use that machine learning model for prediction, we can use actual data or the new dataset for the prediction, and let's assume that we want to predict Apple stock price for March 31st, 2025, where the RSI indicator is 45.12 and NASDAQ indicator is 19,246 and etc. etc. So these are all my parameters. Based on that, if I'll feed those new data to my machine learning model will predict the future level of Amazon stock price. That is how machine learning model works end to end. You can see throughout that process, we have multiple phases or multiple legs associated in terms of building the machine learning model, in terms of model training, creating the training data set, detecting the bias, and deploying that model, and then feeding the new data for production. Now let's review how Amazon SageMaker tool suites can help us for all this process end to end. To start with, we have Amazon SageMaker, and SageMaker used to build, train and deploy machine learning models, that is end-to-end machine learning services. Next, SageMaker automatic model tuning, and it can be used to optimize or tune model hyperparameters automatically. Then we have SageMaker deployment and interface. We can use to deploy models for real-time, batch, serverless and even for asynchronous inferencing. Then we have SageMaker Studio. SageMaker Studio is an unified interface for SageMaker, and it can be used as an integrated development environment or IDE for machine learning. Then we have SageMaker Feature Store. SageMaker Feature Store centralized repository of machine learning features metadata. Then we have SageMaker Clarify. SageMaker Clarify can be used to detect bias, compare models, explain model outputs and explain predictions. Then SageMaker Model Cards. Here we can document model details and their performance. Then SageMaker Ground Truth. SageMaker Ground Truth can be used for reinforcement learning with human feedback, and here we can use human feedback for model grading and data labeling. Next we have SageMaker Data Wrangler. SageMaker Data Wrangler can be used to explore and prepare datasets and create features. Then we have SageMaker Model Dashboards. In SageMaker Model Dashboard, we can monitor and manage deployment models, and we can view all our models in one place. It will be a single pane of glass to review all the available models. Then we have SageMaker Model Monitor, and SageMaker Model Monitor continuously monitor model performance. Followed by we have SageMaker Model Registry. We can use SageMaker Model Registry as a centralized repository to manage machine learning model versions. Followed by SageMaker Pipelines. We can use to automate CI/CD pipelines for machine learning models. Then we have SageMaker Role Manager. SageMaker Role Manager can be used for access control and manage permissions for SageMaker users. SageMaker Jumpstart is a machine learning model hub where you can get all the pre-built models and the solution. Then we have SageMaker Canvas. It is a no-code interface to build machine learning models. And last but not least, we have Machine Learning Flow or ML Flow on SageMaker. ML Flow on SageMaker can be used to manage ML lifecycles with Machine Learning Flow. This summary outlines the tool suite available in Amazon SageMaker, which we will cover in details in subsequent slides or in videos. It should be your go-to reference for all the SageMaker tools and their features. Please pause the video, take note of these tools as they can help you answer 4 to 5 questions in the certification exam. Next, we'll review SageMaker built-in algorithms. Amazon SageMaker offers built-in algorithms, pre-trained models, and solution templates to streamline training and deployment of machine learning models. In this grid, we will compare domains with problem types and the built-in algorithms available in SageMaker. We will also review the input data formats for each algorithm. To start with, we have supervised learning. Here the problem type could be if you want to perform binary or multi-class classification or regression, then the machine learning algorithm will be k-nearest neighbor or KNN or linear learner algorithm and XGBoost. For all these algorithms, the input format will be tabular format. That means you have to input the data in tabular format. Next, in supervised learning, if you want to perform time series forecasting, then the algorithm name will be deep AR forecasting, and again the input format will be tabular. Moving to unsupervised learning, if you want to perform dimensionality reduction, then the algorithm name is principal component analysis or PCA algorithm, and input format would be tabular. Moving to anomaly detection, if you have a use case to detect anomaly, then the algorithm name would be random cut forest algorithm, and the data will be again in tabular format. If you have an workload for clustering or grouping of objects, then you can use k-means algorithm, and again the input format would be tabular. Next, if your use case for textual analysis, that means if you want to perform text summarization or speech to text conversion, then the algorithm would be sequence to sequence algorithm and input format would be text for this case. If you want to perform image processing and if you want image classification, in that case you can use image classification TensorFlow and obviously the input format would be image. If you want to detect object inside that image, then you can use either MXNet or object detection TensorFlow. If you want to use for computer vision, then you can use semantic segmentation algorithm, and for all these use cases you can input image to your algorithm. These are not the only built-in algorithms in SageMaker, but for AI practitioner, these are the key ones to remember. There are some question sets in the exam which includes 1 or 2 questions from this algorithm. If you remember this grid, you can easily answer 1 to 2 questions related to Amazon SageMaker. We'll next move to Amazon SageMaker Automated Model Tuning. Automatic model tuning, also known as hyperparameter optimization, and this is the process of finding the best hyperparameters for your machine learning model. You must be asking, what is hyperparameter? Hyperparameters are the settings that control the training process, and if you can choose those hyperparameters with the right combination, then it can significantly impact or improve your model's performance. Amazon SageMaker performs automatic model tuning by running multiple training jobs with different hyperparameter values and selecting the best performing models for you, and the entire process is automated. To perform the automated model tuning in SageMaker, first you need to define the hyperparameters to tune their ranges. Then you need to specify the objective matrix to optimize, that is accuracy or loss. Based on these first 2 steps, SageMaker will run multiple training jobs and it will find the best hyperparameters for you. The entire process is managed by SageMaker and it allows you to focus on other aspects of your machine learning models. You can go to Amazon SageMaker console, you can choose the hyperparameter tuning job and you can create the hyperparameter tuning job. Once you have created the hyperparameter tuning jobs with different parameters, you can open any one tuning jobs and review them. In the same console, you have the option to view the best training job for you with the best combination of hyperparameters. You can also come to the training jobs and you can see all the available jobs for you that SageMaker has run in terms of automated model tuning. Now let's review different SageMaker model deployment and inferencing options available. SageMaker provides several options for deploying machine learning models, and that includes real-time inferences, batch inferences, asynchronous inferences, and serverless inferences. Let's review one by one. To start with real-time inferences, we can deploy models to real-time endpoints for low latency predictions, and this is ideal for applications that require immediate response such as chatbots or even real-time recommendation system for web or mobile app. And here you can perform one prediction at a time, and it can only support payloads up to 6 MB per file. Now to do that, first you need to select an instance and you can choose either cost per hour or best performance from the available instance types. After selecting the instance type, let's assume we have selected ml.g5 48 extra large instance. The next step is to set the minimum capacity for your workload. Amazon SageMaker provides a real-time endpoint that remains active even if you don't have any application workload. Amazon SageMaker will automatically scale instances based on your application load to handle the incoming requests efficiently. Moving to batch inferences, you can perform batch inferences on large dataset, and this is useful for scenarios where prediction can be made in bulk, such as processing historical data. Now, in terms of data processing, you can store the input data in Amazon S3, and the data format could be either in CSV or in JSON format. From your application point of view, your application will push the data into an Amazon S3 bucket, and then here you are not expecting any output in real time. Then you are going to configure a batch transform job specifying the input data location, output data location, and the instance type. Then based on these parameters, SageMaker will launch the specified instances and process the input data in batch. Then the model will generate the prediction for each batch and store the results in the specified S3 output location. Then your application will retrieve the output data from the S3 bucket and analyze the prediction. In this case, you don't need a persistent endpoint. That is why it will be the most cost-effective option if you have periodic batch processing requirement. Please remember, this is the perfect use case if you have a periodic data processing requirement or if you want to process a large chunk of data. Moving to serverless inferencing. Serverless inferencing allows you to deploy models without managing the underlying infrastructure for you. You can create a SageMaker model using the pre-trained model artifacts stored in S3 bucket. When you are configuring a serverless endpoint, you need to specify the memory size or the RAM and the maximum concurrent invocations for your model. When a request is made, SageMaker automatically provisions the necessary compute resources for you. Whenever you are invoking the HTTP endpoints from your application, the endpoint will scale in and out based on the traffic. During the ideal periods, the endpoint scales down to 0 and it will minimize the cost for you. That is why serverless model is ideal for unpredictable production traffic and the workload if it can tolerate to cold start or application with high latency. Moving to asynchronous inference. Asynchronous inference is designed for processing requests with large payload size or long processing times. As the name suggests, it queues incoming requests and processes them asynchronously, making it suitable for near real-time latency requirements. In terms of model deployment, you can create a SageMaker model using the trained model artifacts stored in Amazon S3. Then you can configure an asynchronous endpoint specifying the input and output S3 locations. Your application will place the request in Amazon S3 and provide a pointer to the payload. When the asynchronous model will be invoked, Amazon SageMaker will queue the request in internal queues for processing and it will return an identifier and the output S3 location. Then Amazon SageMaker will process the request and places the result in the specified S3 output location. You can also optionally configure Amazon SNS for push notification and you can receive success or error notifications via Amazon SNS. Asynchronous inference is suitable for near real-time latency requirements. This model is ideal for large payloads up to 1 GB and if your processing time is up to 15 minutes. Asynchronous inference model can auto-scale to 0 when there are no requests, and that is how it can reduce the cost. Since we have reviewed all the 4 SageMaker model deployment and inference options, it's crucial to understand their differences. Certification exam often include questions requiring you to choose the optimal deployment option based on the use case, payload size, latency, and processing time requirements. Let's compare these options side by side to clear up any doubts you may have. In this grid, we are going to review all the inferencing type based on the latency requirement, payload size, processing time, and the use case. And if you can remember this grid, then you can answer any questions related to the model deployment option selection. To start with real-time inference, when you have a latency requirement of very low from millisecond to second and if your payload size is up to 6 MB per record, and if your processing time is up to 60-second maximum, and if your use case is for fast instance prediction for web, mobile applications, or even for chatbots, then you should use real-time inference. If you have a high latency requirement between minutes to hours, and if your payload size is up to 100 MB per invocations with processing time of maximum 1 hour, and if your use case is for bulk processing of large dataset, then you should choose batch transformation. On the other hand, if you have a latency requirement of low from millisecond to second, and the payload size is up to 6 MB, the processing time is maximum 60 seconds. Till these three parameters, you can get confused between real time and the serverless, but you have to remember the use case. Serverless is optimal for sporadic requirement when you do not know the pattern, or even for short-term inferences, and you don't want to manage and maintain infrastructure, and your application can tolerate cold start or high latency. In that case, you should go for serverless. But if your application cannot tolerate cold start, then you should go to real-time inferences. And last but not least, asynchronous inferences. If your latency requirement is medium to high, that means you have a near real-time requirement. Your payload size is up to 1 GB, very high, and processing time is up to 1 hour. That means if your use case is for large payload and workloads require longer processing time, then you should use asynchronous inference. As I mentioned earlier, you should remember this grid by heart to identify the optimal SageMaker model deployment and inferencing option. Please stay tuned and explore other modules from the bootcamp playlist for a comprehensive understanding of the topics required for the certification. That wraps up this module. If you found this video helpful, please give it a thumbs up, subscribe for more update, and feel free to drop any question or feedback in the comments. We would love to hear from you. I hope this session helped you gain a deeper understanding and brought you one step closer to your learning goals. Thank you very much for watching and learning with us at CloudExpert Solution. See you in the next module.